If I'm doing rise over run, I went down 4 and I went right 2. So remember, down means negative. So I went -4. Right means positive. So I went over 2. -4 divided by -2. Final answer should be a -2. I think I said -4 over -2. It's -4 over +2. I apologize. Final answer should be -2. So -2, -2 over 1 is acceptable as well, especially on the test. Like you would get full credit for either one of those. That's what we're looking at there. Now for number 9, there's a lot of ways you can do it. If I take a second and double check that you guys use point slope form. If we use point slope form, double check here. Okay, so we're going to do it this way. All righty, so to be consistent with the notes, if I'm finding the slope, remember we've got x1, y1, x2, y2 right there. So to find the slope, which again is in your sheet, your slope is right here. You subtract those y values on top, x values on bottom, and you can skip the skeleton step if you want. I personally like it as something minus something over something minus something. Since there's so many negatives, there's a lot of places to mess this up. So I'm going to take my y2 minus my y1. Classic situation right there. A lot of people will write -3 minus 5. They will leave out the red negative. Okay. So you got to have -3 minus and -5 because you're replacing the points for the variables. Okay. So again, a lot of times people leave out the negative there. And then your x2 is going to be -3 minus a 1 right there. So lots of negatives, lots of places to mess this up. You'll have a calculator, which is nice. So you'll keep change on top, and you'll keep change on bottom to have a +2 on top and a -4 on the bottom to get you a -1/2 as your final answer for the slope. Okay. So again, don't really worry about the full red steps after the purple. If you have a calculator, just put it in the calculator. But right now for your equation though, all you've got is y equals -1/2 x plus b. So you still need that b value. Okay. And now what a lot of people do is there's like a lot of ways to do this. They take the y1 and they put it in for this y right there. And they take their x1 and they put it in for this x right there because you still need to solve for b. You don't know what b is. So that gives you a -5 equaling -1/2 times 1. Notice I chose the 1 on purpose because I didn't want to deal with a negative if I don't have to. And so when I add that negative, that stays as a -1/2 right there. So to get b by itself, I have to add it to the other side. So I have to do -5 plus 1/2 equaling b. Again, I have to move the 1/2 to the other side. So I'm left with a -4.5 equaling b. Now let's check that I'm not screwing this up. Yep. So that leaves me with a final answer of y equals -1/2. You could use -0.5. X minus 4.5. The answer key has -9/2, which is 4.5. So this little thing right here is the C is going to be your initial value. So that's like, this is the parent function of a exponential function. So the C is your initial value, and then the B is how it changes per year or just over the period of time. It's either going to increase or decrease, grow or decay. And so this equation we have right here, if we've got that like C times BX in our mind from the formula sheet, that C is your initial value. So that's going to go right there. Now the growth or decay, something is growth if the parentheses is bigger than 1. And something is decay if it is smaller than 1. So as you look at the 0.92, that is smaller than 1. So this is going to be a decay situation, which decay doesn't mean like the car is like wasting away, deteriorating, crumbling. It means like the money's going down. Just in case you're curious, a lot of times it talks about like you can use it for like a body decomposing or something, but decay just means going down. And then super common mistake is people just want to say 92% because they see the 0.92. But it's, you want to go off of 1. So it's how close are we to 1? Okay. So 1 minus 0.92 equals 0.08. So that is my change per year. And this is kind of just like broad definition from the video. So it's going to depreciate, it's going to decay, it's going to go down by 8% each year. So again, you're not going to see 8 in the equation. You're going to see 8 away from 1. You're going to see 0.92. Okay. So if the population is growing by 5.25%, what will the population be after 13 years? So that means I have to do 1 plus 0.0525 to get the inside, to get that B value. Okay. By the way, that B value is very different, not even remotely the same as this blue B value over there. Okay, those are 2 totally different kinds of B values. So that gets me 1.0525. So my actual equation is going to be 360,000 times 1.0525, all raised to the X or time, whatever you want to use. And then to actually do it from there, so that's your equation. And then you'll just put 13 into the exponent right there. So get some practice real quick on the calculator, making sure you know how to plug in that exponent, and then we'll go from there.